Hello, everyone, and welcome to this public webinar presenting the Net Zero Initiative for IT, our latest report on avoided emissions, providing specific guidelines for the digital sector. Today's agenda is pretty simple. After an introduction, Pierre and Benjamin will present you the detailed methodology through two examples, fictive, but still this will be a way to get into the method without having to read all the 85 pages of the report. And I will conclude with the main insights. Please note that this session will be recorded and we will send the link to the replay and the link to the report afterwards to everyone participating or to everyone who had registered for this webinar. There will be no time for questions and answers because we'd rather have you reading the report before asking all your questions. Still, you can ask your question in the chat and the team will try to answer you during the webinar itself. That's it for the functioning of this webinar. And I think we can start because you're already 45 here. And the other people will come during my introduction, so it's not a big deal if they miss the very beginning. So let's go. At first, I would like to thank Clara for her participation in this work. Alas, she could not join us today, but she contributed as well as Benjamin and Pierre to this report. So I'd like to thank her a lot for her work. And so I will do the introduction myself. Our starting point when we launched Net Zero Initiative at Carbon 4 5 years ago already was astonishment because we were seeing lots of claims from various companies and we were wondering, oh, how can all these companies be carbon neutral, right? Because, you know, climate science defines very clearly what global net zero means, what carbon neutrality means. And to summarize this quickly, you may have already seen this in previous Net Zero Initiative webinar, but imagine atmosphere is like a giant bathtub, right? It is filled already with pre-industrial atmospheric CO2, other greenhouse gases. And when humanity burns fossil fuels, we just add some greenhouse gas to this bathtub, increasing the level of the bathtub. Okay? And so our anthropogenic emissions add some CO2, and the bathtub fills, increasing the temperature. This is global warming. Of course, the bathtub also has a sink, a drain, and in fact, there are two non-anthropogenic sinks, which are not accounted in global emissions and removal reports, and anthropogenic sinks, which corresponds to how humanity manages its forests and lawns and more generally carbon removals. And so climate science defines pretty precisely what carbon neutrality is, but how can we decline this at the company scale? That is the central question of Net Zero Initiative. And you see, in the bathtub, there are two things to be monitored. First one is the level of the water. This corresponds to a temperature goal. And this is the famous goal of the Paris Agreement, trying to maintain the water well under +2 degrees of global warming. And there is another goal, which is the carbon neutrality. And this goal is about balancing the tap and the sinks. So closing the tap a lot and removing the dirt from the sink for it to absorb the excess water. This is the neutrality goal, and this is what global net zero means in scientific terms. Okay. And we need to reach global net zero by 2050, roughly. But how can we transpose this for companies? That is the central question of the Net Zero Initiative working groups, basically. And so how should organizations contribute to this collective goal? If I zoom in, so said the global net zero target is about closing the tap and increasing the flux of the sink. So reducing global emissions and restoring and preserving carbon sinks. This is on a global scale. Emissions, we can subdivide it for the IT sector because that's why we're here today. Reducing global emissions means reducing IT sector emissions and also reducing the emissions of other sectors. Now, from an IT company standpoint, this means first reducing the company's own emissions. This is the classical carbon footprint you have heard about. It's your induced emissions. It's pillar A of the net zero initiative matrix. Then an IT company can also try to contribute to reducing the emissions of other companies in the IT value chain. This is what we usually call green IT, or maybe try to reduce emissions of other sectors, what we call usually IT for green. And this is pillar B of the net zero initiative, and it's about avoided emissions. How can my products and services contribute to reducing emissions of others? And finally, the last point is about increasing carbon removals, and so developing maybe financing carbon removal projects out of the value chain, because we're talking about the IT sector. Right. So these methods we published today comes as a complement of the work already done on pillar B of net zero initiative. We have already released a very complete pillar B guide with general methodology for all sectors. And this is a zoom on the IT sector. In this zoom, we start in very general terms to define what I've just explained, in fact, the expected role of the IT sector in the global net zero goal. This is the general statement. It's part one of the report. The part two is the characterization of solutions. We try to shed light on your company's IT solutions and products from 3 different angles in order for you to understand very well how solution can physically reduce emissions, the emissions of your customers. This is the characterization of solutions. It's really qualitative work, but very important work nonetheless. Then there are general methodology items. It's called general, but it's still dedicated to the IT sector, but it's about baseline issues, rebound effects, and so on. And finally, we zoom on 4 families of solutions, trying to provide even more concrete and detailed examples and methods for typical families of solutions of the IT sector. Please note that such guides have also been made by the Net Zero Initiative team for other sectors. And if you're interested in other sectors, you can also consult these guides on Carbon 4's website. We haven't worked alone on this, and I would like to thank a lot our 9 sponsors, Octo Technology, Orange, OVH Cloud, IJO, Bureau Veritas, Constellation, Back Market, Isaïe, and Vision Group, because the sponsors were really committed into trying to apply the methodology for them, for the products, or also to identify the suppliers based on the criteria we developed. And so I would like to thank them all for their commitment. I must also thank a lot our advisory board, an independent group of experts on the IT sector or on avoided emissions or carbon accounting, namely Gauthier Roussil, Julia Meyer, Erwan Fanja, Maxime Fouillès, Pernilla Bergmark, et Benjamin Ninassi. Not all of them are French, actually, but I pronounce it the French way, sorry. And so their proofreading and methodological challenges were really helpful for us to provide a guide of such quality today. So thanks again for our advisory board. This is the classical structure of any net zero initiative project. Sponsor companies, advisory board, and Carbon 4 doing the little work of reading and reading papers and writing the methodology. So thanks to all the team. Now, why should we focus on IT and IT avoided emissions? You probably know that IT today is responsible for roughly 4% of global emissions. So the emissions linked with the IT sector are as big a problem as, for instance, naval transportation, and nearly as big as cars worldwide. And the annoying part is that it has a very, very strong growth, plus 6% per year, which makes the IT sector a very big threat for humanity to reach its decarbonization goals. And on the other hand, on the other side, we hear a lot of things about how can IT or even AI now help the world decarbonize by enabling more efficient systems and so on. And so we wanted to help companies separate what really has a potential for decarbonization and what have no such potential or the solutions which may not be really relevant. And so that's why we released this method today. Please remember that avoided emissions is a very specific indicator. It's not the only indicator in climate action, right? So avoided emissions are calculated in tons of CO2 avoided, and it is a short-term indicator, near-term indicator to help you determine whether your product today is relevant for the world decarbonization or not. And I say the world decarbonization, I should say for a precise market's decarbonization, because avoided emissions are really dependent on the context and on the market. So you can remember that it is a short-term compass and only to decide if a product is relevant now. Other indicators can be imagined as well. For instance, we developed the Paris Agreement Compatibility Score at Carbon 4 in another net zero initiative project. And it is quite the opposite. This is, for instance, a long-term indicator saying if your products are fit for a low carbon future or not. So to perform an exhaustive strategic analysis of your product portfolio, you should examine both indicators and not focus solely on avoided emissions. And so this method focuses only on avoided emissions, but don't forget the other indicators as well. And it's today's focus. So to spare you the 85 pages, at least for now, we have worked with Pierre and Benjamin to illustrate the methodology through two examples. These examples are fictive, and we will develop this example as if we were the companies trying to make their own carbon assessment, avoided emissions assessment, for two solutions. First solutions is from Nimbus Tech, and it's a green IT solution, so IT trying to decarbonize the IT sector itself, but not an actor trying to decarbonize its customers. And Nimbus Tech provides private, public, and hybrid cloud solutions. So it's a simple go-to-cloud service. And the other one is connected water heater by Smart Heat, and it's an IT for green solution. It's about trying to reduce the emissions of the building sector, the use of buildings for people. So it's a connected water heater for a home. All right. And so it tends to heat the water when the electricity is low carbon, for instance. And this is how it should try to decarbonize. But we'll see in the next parts. So I will now let Pierre explain you the very first steps of the process of avoided emissions assessment using the Net Zero Initiative for IT methodology. Pierre, the floor is yours.
Yes. Thank you, Zenon, for the introduction. I will now present the preliminary steps that the report released today recommends before carrying out any kind of calculations of avoided emissions. It consists actually in two parts. You will see first some eligibility criteria, that aim at filtering out greenwashing claims and harmful solutions. And then the second part would be characterization process, as presented in the introduction, to help all solution providers to identify the most relevant solutions in terms of avoided emissions. So if we go to the next slide, first, the eligibility criteria. There are 6 in the report. They were defined as some sorts of gates through which all IT solutions that want to estimate the avoided emissions must go before starting out any kind of calculation. In other words, this would be the first test that a solution must pass to demonstrate that it has a purpose aligned with the environmental transition. It serves as a sort of verification. And if we go quickly through some of them, you see that the first gate would be the do not significant harm criteria based on the EU taxonomy. You also have a gate about excluded sectors, such as fossil fuel exploration. You need to prove your credibility in terms of climate action, but also that your solution has no immediate rebounds. And finally, your solution cannot be an incentive to renewal through a short lifespan or obsolescence. And also that it does not have misleading communication, that it is not called a neutral or zero emission product. And if we take our 2 examples, so Nimbus Tech and Smart Heat, they would, in our fictive scenario, they would pass the test, fulfilling the 6 eligibility criteria. And then when you have validated this, you can go to the second part of the assessment, that is what we call the characterization process. So the report that we released formulates this process to that it consists in 3 main questions that are in the light blue boxes. And all these questions, solution providers should answer them if they want to study the emissions avoided by one of their solutions. So there is the first question about the families of solution. Does the solution belong to the identified families of solutions? In the report, you have a list of relevant families of solutions that is based on the ITU list, which is the International Telecommunication Union. And it provides the main categories of products that could, in theory, avoid emissions. The second one is about decarbonisation levers. Does the solution activate identified decarbonisation levers? There are 3 of them, sufficiency, efficiency, and substitution. And this is, yes, the levers that are activated by all relevant solutions in terms of avoided emissions. And the final one and third one is the operating mechanisms. It's basically the physical ways through which relevant solutions in terms of avoided emissions activates the previous levers in the second light blue box. So then those 3 topics ensure that the solution presents interesting characteristics in terms of decarbonization potential and also in terms of avoided emissions. If all of them, the 3 criteria are validated, then the studied solution may generate avoided emissions. And the next step would be then to calculate those avoided emissions. And this is what Benjamin will explain in the next part. If we look at our 2 examples, so the first one, yes, Nimbus Tech, it would validate all 3 criteria. If we take the first one, it belongs to the optimization of ICT systems family, which is in the list. It also activates 2 levers, efficiency and substitution. And it has the operating mechanism system substitution by replacing the customer's on-premise server fleet. So it is good for Nimbus Tech. And for Smart Heat, the same. It belongs to one of the families, building energy and resource management. it activates two levers, and it also has an operating mechanism, which is system monitoring and optimization, by monitoring the local electricity grid and also optimizing the consumption of the heater. So those two examples would validate the characterization process. And we now can calculate avoided emissions for those two examples. So now I will hand over to Benjamin, who will talk about how to compute these avoided emissions.
Let me just activate, take control of the microphone, camera, presentation. Here we go. So thank you, Pierre. So now that we made sure that our two studied solutions are eligible and may potentially avoid emissions, we can get into the calculations. And to do so, we're going to have a look at the general methodology that was written as part of this report. So before computing anything, just a quick reminder on the definition of avoided emissions. So avoided emissions refer to the positive impact to society when comparing the greenhouse gas emissions of a solution to an alternative reference scenario where the solution would not have been used. So in other words, we have, I'm just going to get my pointer real quick. We have the emissions that did occur with our solutions in deep blue here. And we need to estimate, we need to measure them. And we also need to estimate what would have happened without our solutions in a fictitious counterfactual reference scenario. And this is where lots of the difficulty lies, knowing what would our customers have done in this reference scenario. I can't, yep, there we go. In a context where emissions are overall growing, avoided emissions can sometimes be broken down into two categories. We have the lower increase avoided emissions and the reduction avoided emissions, which are terms that appear several times throughout the report. The main splits between them being the comparison between the solution scenario and the emissions that were occurring initially at the start of when the solution got deployed. So now that we've set the grounds and the definitions of our avoided emissions, we can get into the Net Zero for Initiative for IT methodology for avoided emissions. Which is essentially an application of, as Zenon said, our existing guides for avoided emissions, but with a focus on the methodological cruxes or the pain points that one may encounter when trying to make an avoided emissions assessment of an IT solution in particular. So we basically wrote out the challenges that we can face when trying to come up with a reference scenario or a solution, compute emissions in the solution scenario, and see what are the best ideas to go with to try and build said scenarios and compute said emissions. So when looking at the reference scenario, we can, for example, have some unsustainable trends of the IT sector. This is mainly, as Zenon said in the introduction, the sector is fastly, the emissions of the sector are growing fast. And so it might not always be very clever to claim avoided emissions in such a context. We may be in front of some low-tech alternatives sometimes when assessing a solution. So let's say a high-tech solution may be more efficient than another high-tech one on the market and avoid emissions in relationship to its competitors. But what about if there's a low-tech alternative without any connected aspects or embedded electronics that may also answer the same need? Is that the new reference scenario? We also are confronted with shifting baselines because the IT sector evolves really quickly. Trends occur all the time. And some new technology quickly gets absorbed in the baselines, so must be part of the reference scenario, even if a solution is brand new, it can already be part of the reference scenario if it's deployed very globally. Just getting rid of this. Perfect. So to illustrate with our studied solutions of the day, for example, with the unsustainable trends of the IT sector, we can encounter one for Nimbus Tech. So looking at the rate at which the emissions of the data centers sector are growing, can we really consider that cloud solutions avoid emissions as a whole? For low-tech alternatives, instead of looking at a connected water heater, what about regular non-connected water heaters that would just be used in a smart way by customers that manually tune in when the grid is low? Or to caricature and push things even further, another low-tech alternative could simply be cold showers for this example. And finally, shifting baselines for Nimbus Tech. Once again, cloud services are now everywhere. Every large company has some data stored in the cloud, has some workloads going in the cloud. So it has to be part of the baseline. We have to put it in there somehow. So how do we include them in the reference scenario? For the situation with solution, we also have a few difficulties, such as how do we identify usage that is rebound? So usage that's thanks to the operational efficiency of our new solution, we just start consuming more, and there's some extra demand in comparison to what was there before. So how do we identify and quantify that? Perfect. Sorry about that. So let's say that the customer that made its migration on Nimbus Tech now got rid of certain jobs, so they have less emissions in their, for example, employee commuting. Did these emissions really disappear, or did their employees simply find a new job and commute to someplace else? And for the level of detail required to prove substitution, for example, is the customer buying a smart heater getting a second one for a new house that they use for their vacation, or is it simply replacing their everyday heater and not creating any new demand? So the guide, the methodology gives guidelines on how to treat each one of these methodological cruxes and give tips on how to go through with the calculations of the reference and solution scenarios. And with that all in mind, we can start following the usual method for avoided emissions calculations, starting with specificity. So specificity is basically looking at how specific do we want to be on the product for which we're assessing avoided emissions and the context to which we are comparing ourselves. So for example, with Nimbus Tech, we're going to be in the very high specificity category. We're going to be looking at a specific solution by Nimbus Tech that's deployed for a specific customer A, that we're going to name him customer A for the rest of the slides. And we're going to look in the reference situation at what customer A would have done in their specific situation without Nimbus Tech, and not what the average company does whenever migrating on cloud. We're looking at this exact case. If we get less specific for the reference scenario, for example, we can see the way we're going to go for smart heat, or we're going to compare a specific solution by smart heat, so their latest connected heater. And we're going to build the reference scenario using data from their average customer base, thanks to surveys that were led upon smart heat's customers. Why did we make these choices? So this is illustrated throughout the report, but for cloud services, for example, cloud solutions, the fact that a cloud migration is very complex and there's many architectures to choose from, many services to choose from, so many ways to complete a cloud migration, coupled with the fact that it's easy to use, it's scalable, so there's a very high chance of rebound effect. This has led us to impose Nimbus Tech to choose the highest level of specificity possible for their avoided emissions claims. So as was just mentioned, we're going to look at one specific customer A today. So they can't communicate saying, thanks to our highly optimized services, we allow each of our customers to reduce their information systems emissions by 80%, and we avoided 22 kilotons of CO2 in total. Instead, we're going to have some specific user cases and communicate on them. For example, company A has trusted us to migrate their information to our private cloud, or public cloud in our example. So we avoided 500 tons of CO2 for this specific customer. For smart heat, the solution is not as prone to the different pain points, methodological cruxes mentioned in the report on specificity. So they're allowed to choose a lower level and not to compare, not to look at a single Mr. and Mrs. X and their household that bought a heater, but look at their average customer base, thanks to surveys that they led among the customer base. And the interesting thing is, because of the connected nature of their solution, they can also collect some real data on their customers' electricity consumptions and habits, which is going to come in handy when computing the emissions of the solution scenario. Once the specificity is done, we also have to set a temporal and geographic frame for our study. So for Nimbus Tech, we're going to be looking at the emissions that occur over a full year of customer A using services from Nimbus Tech. And in France, as it's the region chosen by customer A for their migration. And for smart heat, we're going to be looking at the full lifespan of a heater, which they estimated at smart heat as 10 years for a customer base that is mainly in Germany. These are just examples. And an important thing to note here is that all emissions linked to electricity consumptions must be computed using the location-based methods, as we want to be as close as possible to the physical reality of emissions that are occurring because of the use of the considered solutions. Now that we have our time and geography perimeter, we need to define a functional unit for our study. And to avoid as much as possible falling into forgetting about any rebound effects, we're going to be looking at a full year of use of customer A's information system as the functional unit for Nimbus Tech. So we're not going to say Nimbus Tech emits some kilograms of CO2 per stored terabyte or per virtual machine deployed or per any type of computing capacity, because that would invisibilize potential rebound effects where the number of terabytes stored just grows 3 or 4-fold, and absolute emissions grow, but in intensity they don't. So to avoid all that, we are simply going to take the whole perimeter, whole picture, and look at the emissions occurring during a full year of customer A's existence of their information system. For smart heat, we're also going to try and avoid potential rebound effects by not counting emissions in, for example, kilograms of CO2 per kilowatt hour, and simply by counting the emissions by heater, so by household that purchased a smart heat heater. This allows us to avoid emitting effects such as customers taking warmer and longer showers, knowing that the electricity is low carbon on the grid right now, and finally consuming more kilowatt hours. We have our functional units. Our last step is to define our carbon perimeter for the study. So what emissions are we going to count? The toolbox at the end of the report luckily gives some guidelines on what is to include for any type of, for example, connected solution or cloud solutions. And so for Nimbus Tech, we're going to have the manufacturing, electricity consumption, and end-of-life emissions of all hardware hosting their customers' activities. We're also going to have the electricity consumption of any supporting equipment, such as cooling devices, lighting within the data center, etc. And also count the emissions linked to refrigerant fluid leaks. Other emissions, such as building the supporting equipment or building the data center itself, employee commuting, etc., can be counted if it was counted in the reference scenario to compare things with the same perimeter. However, they're optional, unlike the other emissions that were just mentioned, as they most likely do not count for as much. And for smart heat, same thing. We're going to go with the manufacturing, use phase, and end-of-life equipment emissions, of the concerned equipment, so of our heater. With all that said, we can finally get to building our reference scenario for both our solutions. Luckily enough, again, we have a decision tree for example, cloud solutions to try and set the most precise reference scenario, or the most adequate reference scenario. So it might appear a bit small, but we're going to go through questions on the left here. So first thing we need to ask ourselves, so Nimbus Tech is very specific. They led a survey. They inquired with customer A specifically about their need. They're going to ask them, so is the solution a new demand or an existing demand? Does it replace or upgrade an existing information system? So in our case, customer A did have its on-premises servers before. So we're going to follow the red arrow on the right. If it were a new demand, we'd have to stop here and compare ourselves to the market average of other cloud providers. Then what happens to the servers that were initially used? So customer A said they mostly decommissioned their on-premises servers. If they were mostly kept in the same place, powered on, we would probably simply stack the cloud solution on top of the existing on-premises and have no avoided emissions. That's not the case, though, so we can keep on with the assessment. What type of cloud services will customer A subscribe to? Mainly public cloud. And then an important question here is, does Nimbus Tech in its communication have incentives or phrases to fight rebound? Because public cloud services are very easy to use, very scalable, and can be considered as a driver of the overall inflation of data consumption in the world. So if there is no clear communication on the need for sufficiency, the assessment stops here. However, Nimbus Tech is clean on their communication and talk about the need for sufficiency and the need to question needs. And finally, is customer A's migration motivated by the reduction of emissions? Yes, when they were surveyed, so this is a fictive, customer A placed the potential reduction of emissions as the main driver of their cloud migration above operational efficiency gains. And therefore, our reference scenario, as per this decision tree, is customer A's initial on-premises emissions that they computed in their year -1 carbon footprint. They counted their number of servers, their electricity consumption on-premises, etc. And it amounted to 1,000 tons of CO2 over a full year. So these are our reference scenario emissions. For smart heats, as we said, they have a customer survey to build their reference scenario to see how their customers would have behaved without the existence of smart heat. And among they had a good response rate that was deemed representative enough to build the reference scenarios. And among the respondents, 10% have said they would have bought another connected water heater from a competitor. And Smart Heat carried on with their internal calculations to find out that this would equate to 6 tons per heater over a full lifespan of 10 years. 10% said they would have kept their current heater. And thanks to other data in the customer survey, Smart Heat was able to compute that this would mean on average 12 tons of CO2 per heater. 70% would have bought a new regular electric water heater, so not connected, not smart. And this would amount to 15 tons of CO2. And finally, 10% would have bought a gas-powered water heater for 18 tons of CO2 per heater. And the reference scenario is simply going to be the pondered average of these customer responses to the survey, amounting in total to 14 tons of CO2 per heater over the full lifespan of 10 years. We have our reference scenario emissions. Only thing left is to compute the solution scenario emissions. So for Nimbus Tech, as we mentioned earlier, we need to compute the cradle-to-gate electricity consumption and end-of-life emissions of the hardware. We also need to take into consideration fluid leaks and consumption of cooling equipment. And to do so, so customer A uses public cloud services. They don't have their dedicated machines in a Nimbus Tech's data center. So what Nimbus Tech can do is simply consider all of the hardware that's used for the public cloud services in the considered region of France. And also very important, using location-based electricity emissions. And using an allocation key, they can give some of these emissions to customer A. The allocation key must be transparent and has to be communicated, but it can be, for example, revenue. So let's say Nimbus Tech's hardware hosting public cloud services in France emits 200,000 tons of CO2 during the chosen year, and 0.25% of their revenue comes from customer A. This equates to 500 tons of CO2 for customer A. Regarding the supporting equipment and the fluid leaks, they can follow the same reasoning. So taking their full emissions and reallocating it to customer A thanks to the revenue that their spendings bring in. And in total, we have our solution scenario emissions, which amount to 550 tons of CO2 over 1 full year after customer A has completed the cloud migration. For Smart Heat, so same old song, cradle to gate emissions, end of life, use phase. To compute these, so for the manufacturing and end of life emissions, luckily Smart Heat did pass through the gates of climate action credibility. They did compute their carbon footprint, and they also have precise, detailed carbon footprints for their products. So they do have the manufacturing emissions of their heater. They have the end of life emissions, and for the use phase emissions, they're going to take advantage, as we mentioned earlier, of the data that they gather on their customers' usage of the connected heaters. So for the cradle to gate emissions and the end of life emissions, it's in their product LCA, life cycle analysis. And for the use phase emissions, they're going to look at the average emission factor of electricity in Germany as consumed by a Smart Heat heater over 10 years, based on all the real data that they gathered. So let's say that the average emission factor for Germany may be, for the next 10 years, 250 or 300 grams of CO2 per kilowatt hour. Smart Heat can use a lower emission factor thanks to the real-time nature of the electricity consumptions that they have, and simply prove that electricity was pulled from the grid from Smart Heat heaters at times where the emission factor was lower. We can cross this smart heat specific emission factor with the average consumption of a smart heat heater over 10 years, which again, thanks to the data they collect, is precise and is known as 30,000 kilowatt hours per heater. And we get 4.5 tons of CO2 per heater over 10 years. Another way they could have measured this is by simply looking at a graph of the German electricity emission factor over 10 years and cross it with how strongly does the fleet of smart heat heaters in Germany pull on this grid according to different times, and land on the same value. So in total, we just sum all of these emissions up and we get approximately 6 tons, so 5.8 tons of CO2 per smart heat heater over 10 years. We've got our reference solution, our reference scenario emissions and our solution scenario emissions. All that's left is to compute the difference, the easiest part of the assessment. And we land on our feet. We get 450 tons of CO2 avoided by Nimbus Tech for customer A over 1 year. Very important to note that if there are a strong increase in IT usage from customer A, we can end up with a solution scenario that is more emissive than its previous on-premises scenario. And in that case, no avoided emissions. And for smart heat, thanks to the customer survey and the real-time and the measured collected data, we're able to compute that overall, one heater on average avoids 8.3 tons of CO2 over their full lifespan. That's it for our use case. I'll let Zenon take the microphone and screen again. So just 1 second. For some reason, I'm disconnected of Zoom. Can you still see me on your screen? Yeah. Okay. All
right.
Let me just shut off.
Great. Thank you, Benjamin and Pierre, for this presentation, and thank you all for your reactions in the chat. There are already several questions and discussions going on. Sorry, I could not answer all of them in time, but we will, in the recap email with the links, we will send you as well the answers to, or elements of answers to the remaining questions. We've been through almost the complete guidance with these two examples. Now the question is what to remember and what are the main insights if you had only a couple of minutes to think about the avoided emissions for your products and companies. I would say that first, I've already said it before, but it's really important to remember the goal of the avoided emission indicator. It is really a compass to determine if your product is relevant today to decarbonize a precise market. Then remember also, before doing any calculation, please understand how physically your solution can or cannot avoid emissions in your value chain. And so really do the qualitative analysis we suggest at the beginning of the document, using the characterization of solutions, the eligibility gates, and try to understand really what happens physically. Also, you have noticed IT topics tend to be very complicated regarding avoided emissions. And so in this method, we really step up in terms of expectations regarding data quality. It's time for data-driven companies, or so-called companies, to demonstrate that they are indeed data-driven and to provide the proper data to prove that they have a positive impact on their ecosystem. So the method was built in quite a conservative way to counterbalance all the claims we have seen in the past few years on the sector. So really, data is key here in all avoided emissions calculation, of course, but especially in the digital sector. And same, the rebound effect is everywhere in the IT sector. And so we encourage companies doing avoided emissions calculations to not to underestimate these rebound effects. And so every avoided emission calculation should come with a carbon tipping point calculation as well. So if my decarbonizing product is being used a bit more than what I've expected, or maybe much more than what I've expected, does it reaches a point where, in fact, it's not avoiding emissions anymore? We've seen that in heat pumps in the building sector, in travel, everywhere as well. It's also a really big problem for IT. And so companies should be extra careful regarding this. And an avoided emission assessment cannot be considered rigorous without such calculations of carbon tipping points or similar ways to investigate rebound effects. So you can also remember that we have studied 4 families of solutions. We have provided 2 examples today, but these families of solutions are broader than these examples. The first family we have studied in detail is about circularity, any kinds of solutions that tend to increase the lifespan of products by reuse, repair, recycling, and so on. Also, we have studied cloud and virtualization solutions, anything that tends to replace or improve servers architecture in order to decarbonize the IT sector itself. And we have 2 more families of solutions, demand and offer matching platforms. So for instance, BlaBlaCar for car sharing, trip sharing platforms, but other similar platforms can also investigate their avoided emissions cases using the detailed section of the toolbox. And finally, demand-side optimization and sufficiency. This is closer to the example of the water heater we have seen today, some device that brings information to the end customer, helping him or her having a more responsible behavior or a more responsible consumption, and sometimes forcing him, for instance, if you change the default resolution on video platforms, this could be seen as demand-side sufficiency and forced sufficiency, I should say. So the report contains many details and answers many questions. We have also included many graphs, many figures, decision trees, equations, histograms everywhere, other decision trees, and so on. So if you want to know if Bob would have taken the same car as Alice in a given scenario, then you should definitely read the report. We've also detailed things for rebound effects, higher order effects, and so on. All of this to provide companies with qualitative and rigorous methods for their avoided emissions assessments. That's incredible. So definitely read the report to go further. And you can also join the community. Maybe you want to be a sponsor of a potential season 2 of Net Zero Initiative for IT. Then, of course, feel free to contact us. Examples of topic we could treat in another season could be simply to add more families of solutions in the guidance, or maybe to calculate the Paris Agreement alignment score for the IT sector. It could be interesting as well. How can I determine if my IT products are relevant in a low carbon future? It's basically the same question. So feel free, of course, to share this report. It will be labeled under Creative Commons license. So you can use it even for commercial purpose. Just make sure you quote the authors, including Carbon 4 as a company, and make sure the content stays the same, of course. That's it for today. thanks to all of you, and thanks to my team who have worked very hard on this topic, and for the sponsors who have supported us for 1 year now. And of course, for the advisory board for the review of and challenge of the method itself. Have a nice evening, everyone, and looking forward to discussing further avoided emissions in truncated cases, maybe in September with you. Goodbye.